Look at the physical weight of a poorly designed survey. When researchers append every possible demographic and control question they can think of, they create an instrument that collapses under its own bloat. We are following Dr. Mira as she audits a research proposal suffering from this exact problem. Her objective is to ruthlessly optimize an overloaded draft. There is a common misconception in survey architecture. Many assume that demographic questions are harmless spoiler text, a standard block you simply paste at the end of every study. An overloaded survey forces high respondent fatigue. When participants face dozens of irrelevant personal questions, they begin straightlining, checking the same response down a column, or abandon the instrument entirely. Even if they finish, you have introduced statistical noise. Throwing in unjustified variables as controls threatens the internal validity of your study by muddying the actual relationships you want to measure. Professional survey architecture demands a different standard. You must mathematically and theoretically justify every single variable included in the instrument. A bloated survey design compromises your data integrity. It weakens your statistical analytical models from the ground up. This dashboard separates variables into two categories: sample description and variance reduction. Demographics belong in sample description, mapping the captured sample's parameters. Control variables operate differently. They are metrics injected into your model to rule out alternative explanations for the outcome. Blurring the lines between these two functions leads to flawed research architecture. You cannot use a descriptive tag to do the mathematical work of isolating variance. Misclassifying a simple descriptive demographic as a control variable breaks the theoretical framework of the study. The first step in auditing an instrument is a ruthless editorial reduction, applying a strict filter to every proposed question. We must ask, does this respondent characteristic actively and logically influence the specific outcome being studied? Defaulting to standard questions like age or income is invalid if your research question focuses on independent workflows in a software environment. Forcing respondents to answer highly personal, theoretically irrelevant questions places an unnecessary cognitive burden on them. The rule is absolute. If a specific variable cannot be directly tied to the primary research question, you must eliminate it. Failing this filter proves the variable is a distraction, collecting dust rather than valid data. Every single variable that survives the first cut must pass a theoretical mapping test, clearly backed by prior academic literature. This graph represents our primary theoretical model, plotting a direct causal pathway from the independent variable to the dependent variable. An extraneous control variable impacts the dependent variable, but it exists completely outside your main hypothesis. A danger arises when a control variable intersects the main hypothesis, creating a confounded, invalid theoretical model. Warning tone. Injecting new variables without rigorous theoretical justification risks severe data dredging, leading your analysis into entirely spurious correlations. This sampling map illustrates how the selection of demographic variables is a downstream result of your chosen sampling strategy. If you select simple random sampling, your demographic questions must prove that the sample accurately reflects the broader target population. Stratified sampling imposes a mathematical requirement. You must measure the exact strata, like corporate roles or geographic regions, that define your groups. With cluster sampling, the survey must record specific cluster-level identifiers, such as project sites or institution branches. Quota sampling introduces rigid constraints. Your demographics have to track exact progress against pre-planned categorical limits. In purposive sampling, demographic questions serve strictly as eligibility gates. They exist solely to prove the respondent possesses the required expertise to participate. For convenience and snowball sampling, demographics are used to map network bias and clearly disclose the limitations of the research reach. Survey architecture is a mathematical consequence of your methodology, not an independent creative exercise. There is one final advanced justification for retaining demographic variables: planned structural comparisons, known as multi-group analysis. You should only build distinct categorical variables if you mathematically intend to split the dataset for comparative modeling. This cross-tabulation table shows exactly how categorical data functions in analysis. The degree program variable is mapped directly against the quality of feedback outcomes to isolate differences between the groups. Failing to plan for this analysis results in collecting categorical data that sits unused, frustrating respondents for zero analytical gain. Multi-group analysis justifies demographic collection only when a direct group comparison is required by your hypothesis. To ensure a streamlined instrument, run your final draft through a strict methodological checklist. First, does the question explicitly support your sampling strategy? Second, does it perfectly match the research question? Third, is the variable supported by prior literature? Fourth, does it genuinely influence the dependent variable? Fifth, is the variable specifically required for subgroup analysis? And sixth, is it ethically framed for the respondent? Passing this audit transforms a bloated, disjointed survey into a rigorous, elegant instrument. With every single question now rigorously justified, you move confidently into data collection with an instrument built for precise statistical inference. Optimal demographic design aligns each variable with the study's specific sampling logic and theoretical framework.